Let us look at the solutions for the 2017 examination paper. As I've indicated previously, these are the solutions that I'm presenting. It is possible for you to have had a slightly different solution arriving at the correct answer as well. If we look at question 1.1, you had to display the sentence, "It is fun," set the background color to lime and the font size to 15. So that needed to have been done in a panel. So it's the panel.caption that needed to change to "It is fun." The property font.color had to be sent to CL. All colors have the prefix CL and then the color name. And font.size is set to 15. If we look at 1.2.1, determine and display the larger of the number. So we've got two numbers. We input the first number, num1, and we input num2, convert them after receiving them from the text, from the edit boxes, and then do a simple check. If num1 is greater than num2, then obviously num1 is the bigger, so we display num1. Else, if num2 is bigger than num1, then num2 is the bigger. And then final else would mean num1 is not bigger, neither is num2, therefore they have to be equal. 1.2.2, you had to swap the contents of two variables. So here we had to get two words. We get the first word from the edit box, we get the second word. In order to do a swap, you would recall from one of my previous videos, we introduce a temporary container. So here we have a temporary variable. We take the first word and put that into the temporary variable to store it so it's not overwritten. Now we can override a word 1. So we take word 2 and put that into word 1. And finally, we take the temp and put that into word 2. That's a basic 3-step swap that takes place. And thereafter, we display them in the edit boxes. If we look at 1.3.1, here we had to display the picture that represents the number of cakes. So if 4 cakes were selected from the combo box, then a picture with 4 cakes was meant to be displayed. If 5 cakes were selected, then the picture with 5 cakes should be displayed. And you had to also calculate the cost of the cakes. So to achieve this, we've got a constant called price, which is the price of the cakes. So we get the total number of cakes. This is not a local variable because num is also required in another procedure later. You will see that just now. Therefore, num is declared as a global variable. We get the total number of cakes and take that number and multiply it by the constant, which is price, to get the cost. That is displayed to 2 decimal places. We use the float to string f, ff currency, 5 spaces total, 2 after the decimal point. Now to put to get the picture name has to be put together. So you take the word, so all the files are either picture 1, picture 2, picture 3, and then you join it to the number, however many you have. So if num is 3, then 3 will be joined to the word pic, and then that is then joined to the .png. So this is how the file name is put together, and when called in a picture.load file, load from file, that particular file name will be loaded. If we look at 1.3.2, you had to calculate the amount of sugar in grams that was required, and then determine the number of 1 kg packets of sugar that was needed to be purchased. So here again, we have a constant sugar that's set to 375. To get the total number of grams, it's the sugar 375 times a num. Remember, num was the number of cakes. That's a global variable. So that would tell you the total number of grams that is required. That's then just simply displayed here. So how do we now display the number of packets of 1 kg sugar that's required? In this case, we simply take the number of grams and divide it by 1,000. Here, we use a function called ceil, which is short for ceiling. So what ceiling does, it takes any real number. For example, if you had 1.3, that number will automatically be converted to 2. If you had 1.7, that will be converted to 2. Similarly, if you had 1.9, it'll be moved to the ceiling, which is 2. Unlike a round, which will only convert if the number after the decimal is a 5. So here, if I end up having 1.3 kgs of sugar, or rather, after dividing the number of grams by 1,000, and if I end up with 1.3, it means I'm going to need 2 packets of sugar. Therefore, ceiling is the function that I require to take the value that I get and move it to the next integer number. Let's look at 1.4. This uses a radio group. It's got the owner, it's got the customer, and it's got a staff. If owner or staff is selected from the radio group, then you need to display the panel, otherwise the panel, you hide the panel. So here we check if the radio group item index is 0, that was the first one. In the first one, that was the owner. So if the index is 0, the visible property is set to true. The second one was the customer. So with the customer, if the item index is a 1, it's not visible. Else would mean it's not a 0 or 1, it has to be the 2. And with the 2, that represents the staff member, and the panel is made visible as the question requires us to. .4.2 requires a password. Determine whether the password is valid or not. A valid password must satisfy the following criteria. It must consist of at least 6 characters. It's easy for us to check. If it has 6 characters, we can use the length function. The first character must be a capital letter. That is also easy for us to check. We can treat the string like an array and look at position 1 and check if that's a capital letter in terms of uppercase. The third is the password must contain 2 or more special characters, which is a $, at, a hash, or the ampersand. To achieve this, we need to run a loop checking each character, and if we find one of these characters, then we will have a counter to just increment. And at the end of the loop, we will know how many of these characters we have. Let's see how that translates into code. We get the password. We find the length of the password. That will satisfy the first criteria to check if that is greater than or equal to 6. Then we look at how we can satisfy the third character to see if it has those special symbols that they talk about. A loop is run starting from 2. There's no need to start the loop from 1 since the first character is an uppercase letter. We want to find a special character from the second character onwards. And as the value of I changes, we're then looking at different characters in the password. And each time we're looking at a different character, we're checking if it is in that particular set. In other words, if that character is one of the ones in our set. And if the character is in the set, then we have a counter, which was initialized to 0. And it simply increments by 1 every time the condition is true. So as I constantly changes and it finds a particular character in that set, the counter increments. And this loop just continues. I keeps changing, looking at different characters until the end of the password is reached. The last character in the password is reached. After that for loop, we then check to see all 3 criteria is met. So if the length is greater than equal to 6, the first character, password 1, is uppercase. In other words, it's a capital letter. Equals to uppercase password 1. If it's a capital letter, it should equal to the uppercase of that, which is also a capital letter. And if count equals 2, count was obtained from this for loop. Then it means it's a valid password. If it is a valid password, that particular button is enabled. If those 3 conditions are not satisfied, that means it is an invalid password. Let's look at 1.4.3. In this question, we need to change the first letter of a valid password to the next letter. In other words, the first letter, if it's an A, it should become a B. If it's a B, it should become a C. If it's a C, it should become a D, and so forth. And then they say the Z, the letter Z, should become an A. So how would we go about coding this? Here, we make use of a function called successor. Successor is a predefined function. It takes a character, so I'm giving it the first letter, which is what we want to check. We needed to check the first letter of the password. So we take the password position 1 and we change that to the next letter of the alphabet. And once that is changed, we put that back into position 1 of the password. But before we do that, we first check, and this is important to do first, we first check if it is a Z. If password position 1 is a Z, then change that to an A. But if it's not a Z, it means it had to be a letter from A to Y. In which case, if you find the successor, it will just change it from the current letter to the next letter of the alphabet. So it was important to first make the check for a Z. And if that check fails, then you change to the next letter of the alphabet. 1.5.1 requires checking whether the number entered is a perfect square or not. A perfect square. What is a perfect square? A perfect square is a number like 9. 3 times 3 is 9. Or 16. 4 times 4 is 16. Or 25. 5 times 5. Or 36. 6 times 6. So in order to determine if something's a perfect square, we need to find the square root and determine, look at the result of the answer. For example, the square root of 36 is 6. Actually, it's 6.0. Why is 37 not a perfect square? Because the answer there is 6 point, I'm assuming 1 something something. So a perfect square is when you find the square root and the fractional part. The fractional part is 0. as opposed to any other number which is not a perfect square, the fractional part will not be 0. In order to achieve this, we input the number and we find the square root using the square root function. Remember that square root always returns a real value. Now, if that root, which is in this example 6.0, square root of 36, if that root equals to the trunk of the root, trunk is another function that drops all the remainder. So it takes 6.0, it drops it as drops the remainder, and it will return 6. So if the square root, which is a real value of 6.0, equals to the truncated part, then it has to be a perfect square. Because in this instance, when you truncate 6.1, you get an answer of 6. And the square root value and the truncated part of the square root are not equal if it's not a perfect square. But in all instances, when it is a perfect square, the square root and truncated part of that square root is equal. So if root is equal to trunk root, then it is a perfect square. Otherwise, it is not considered a perfect square. Let's look at the last question, which is 1.5.2. Here you have the sequence 1, 3, 9, 27, 81, 243, 729. So the first term always starts off with a 1, and every subsequent term is multiplied by 3. So 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, etc. So we need to generate a whole bunch of these terms until you get a sum. The sum of this sequence just exceeds a value of 1,000. The minute the sum exceeds a value of 1,000, it should stop. In other words, 1 plus 3 plus 9 plus 27 plus 81. In that sequence, the minute it exceeds 1,000, the sequence should stop. Immediately reading the question, we need to understand that it isn't fixed repetition that's involved. We don't know how many times a loop is going to execute to give us the sum just greater than 1,000. So this is conditional repetition, where we will use either a while loop or a repeat until. In this solution, I will make use of a while loop. We are told that the first term is a 1, so there is a variable called term that's set to 1. And if that is the first term, then I need to track the sum, and the sum will also be 1. Let's leave this statement where sequence is performing some instruction. Let's leave that out for the time being. So while the sum is less than 1,000, we need to continue with the repetition as long as the sum is less than 1,000. Let's get the next term. And as we said, 1, 3, 9, 27. So I've already got the 1. I need to take that and multiply it by 3 to get the next term. So term takes on the current value, and multiplied by this constant. And you will see that there's a constant variable multiplier, which is set to 3. So every time I multiply this, it's multiplying it by 3. So I take 1, multiply it by 3, and that gives me the next term in the sequence. I then accumulate, I sum it up. I sum up that term. So sum would have 3 plus 1, which is 4. As I indicated, let's come back to that statement. I then go back up and check if the sum is less than 1,000. Yes, it is. Therefore, the repetition continues. I get the next term by taking term, which is now 3, and multiplying that by 3. So 3 times 3 gives us the following term, which is 9. And then sum equals sum, which was 3 plus 1, 4, plus 9, giving me 13. So this loop is going to continue each time, generating the next term by multiplying it by 3 and then accumulating the term, so that when the condition is tested, we can determine whether the sum goes over 1,000 or not. Once the sum goes over 1,000, this condition will become false and the loop will stop. So what is this variable sequence doing? In this question, you are required to display this sequence one next to each other. In other words, we did not want them to be displayed one below the other in that fashion. It needed to be displayed in a sequence on one line. To achieve that, we create a string variable sequence. It's a string variable. And we set that to the first term, which, because term is an integer, we'll do a conversion, and then we leave the space between the term. And every time we generate a new term, we add the previous sequence. So that's an accumulator. We add the previous sequence. We take the new term that we would have generated. We add that to the sequence, and then we add a space to it. So all that this variable seq is doing, it's building up or accumulating a sequence that's made up of the numbers 1, 3, 9, 27, until eventually the loop finishes, the condition is false, the loop finishes and terminates, and then the value of the sequence is displayed. I repeat, with the while loop, in a previous video, I indicated make sure that when using a while loop, it always follows the principle of ITC. T is what you are testing. In this instance, we are testing sum. And because you're testing sum, you have to make sure that sum is initialized. Sum in this case is initialized to 1, and I am able to test it. If you don't initialize the value, it does not have a value to test. And then inside the loop, make sure that you change the value of the variable you are testing. So here, sum takes on the value sum plus term is where the change is taking place, so that when it goes back to the condition, a new value is tested. I hope this helps you.